Okay, good morning all. I'm Amit Kumar Shinde. I welcome you all for this today's session. And in this today's session, we are going to discuss the introduction related to the composite materials and nanomaterials. In this, we are going to discuss what is the meaning of composite material, then its general classification, then its properties, and few applications. In the same way, I'm going to cover the nanomaterials with respect to its introduction, specific properties, and then its types. And at the end, we will discuss some applications of the nanomaterials in our day-to-day life. Okay. Now, I will start with the composite material. What is the meaning of composite material? Here, I have highlighted that. Now, composite material, it is nothing in short. It is a material made from two or more different materials, or it is made up of two or more constituent materials having different physical and chemical properties. Okay, two or more different materials will be combined, which are having different physical and chemical properties to give rise to a new material, and this new material will be having different physical and chemical properties as compared to the parent material or its constituent elements. Okay, this will be termed as composite material. Now, what is the basic highlight of this composite material? If you compare this composite material with the different mixtures or solid solutions, you can find that in case of mixtures or solid solution, whichever parent elements are there, they are not easily, or they are not easily identified. Okay, you cannot identify the parent elements in the mixture or solid solutions from which that material is made. But in case of composite material, whichever constituent elements or parent elements you have used, easily you can identify it, because in composite material, the individual components remains same and distinct. Okay, they remains same, or you can say that remains separate and distinct in the finished composite material. If you compare them with the solid solutions or any other mixtures of two elements, this is the means unique characteristic of composite material. That is, whichever parent element you have used, they can be easily identified separately and distinctly in the finished structure. Now, why we are going for this composite materials? Okay, we are having separate elements, but uh, in the modern living demands, okay, we are demanding some special characteristics, or we want the combination of the properties. Okay, suppose, for example, I will give you one practical example. Okay, that is the vehicle tires. Okay, vehicle tires we are manufacturing with composite materials. Okay, vehicle tires. Now, how these vehicle tires are manufactured? These vehicle tires are manufactured by the composite materials, and that composite material contains nylon material and steel fibers. Okay, or steel material. It is combination of nylon and steel material. Now, as it is a composite material, it provides the combination of nylon properties and steel properties. Okay, steel will give you the required strength. The required tensile strength will be provided by that steel material, and whichever nylon material is present, it will give you the required ductility and toughness. Okay, required ductility and toughness while using the vehicle tires. Okay, in this way, these composite materials provide us the wide variety or wide combinations are available as for our use. We can make the diversify large kind of diversification in the composite materials depending on our practical needs. This is the very important characteristic of composite material. That's why nowadays lots of research is going on the composite material, and largely these composite materials are having applications in aircraft industry or in space vehicles, in rockets, in building constructions. Okay, why we are using these composite materials there? Because these composite materials will provide you the required amount of strength with better corrosion resistance, heat resistance, and they will provide these characteristics with lightweight also. That's why they are having wide applications in aircraft industry or in the space vehicles. Okay, now these uh, now these composite materials are broadly classified in two different types. Okay, depending on the nature of their existence, we are having two types of the composite materials: natural composite materials and man-made composite materials. Okay, depending on their nature of existence. Now, the composite materials which are in existence by nature or they are naturally occurring, that will be termed as natural composite materials. An example of this natural composite material, wood material or bamboo material is example of natural composite. This wood or bamboo is made from uh, two materials, cellulose and lignin. Okay, both wood and bamboo, it consists of two separate materials will be there, or two elements will be there, cellulose and lignin. If you observe them carefully, these two are separately visible also. Okay, separately visible or distinctly you can see in the finished product also in bamboo or wood. Now, in our human body, different bones are there, and all these bones are example of natural composite material. Okay. Our bone is also example of a natural composite. Now, this bone consists of two constituent elements, that is collagen and apatite. Okay, collagen and apatite. Okay, so in this way, you can these are natural composites existing naturally, hence they are termed as natural composites. The composite materials, okay, which are made artificially, okay, which are made artificially, that are termed as man-made composite materials. Now you can see here different examples. Concrete material, okay, concrete, that is the example, concrete mixture which we are using in the construction. Okay, and this is the sand, mixture of sand, water, dust, cement. Okay, this will be termed as concrete. Then the FRP and fiberglass, this is fiber reinforced plastic. What is meaning of this fiber reinforced plastic, that we will discuss in the later hub. Just now remember the name, fiber reinforced plastics. And fiberglass, what is the meaning of this fiberglass, or how they are manufactured, how FRP are manufactured, that I will discuss in the remaining part. Now, mm, after this natural composites and man-made composites, we will move towards the next classification of this composite material. Okay, depending on the how the arrangement, okay, how the arrangement of one material into another material is done, or their nature of distribution, the composite materials are classified in three different types. Okay, three different types are there. The first type is fiber reinforced composite materials. Second type is laminated composite materials. The third type is dispersed composite materials, or these dispersed composite materials are also known as particulate composite materials. Now, one by one, we are going to discuss these along with their specific properties and applications. We'll start with the first composite material, that is fiber reinforced composite materials. Now, in this fiber reinforced composite materials, or this fiber reinforced materials, how these are made? Now, the fibers, one material is taken in the form of fibers having high strength, and these are introduced into soft and ductile matrix. Okay, I will show you the diagram of this fiber reinforced plastic. Okay, these are the last diagram. These are types of composite materials. This is fiber reinforced plastic. Okay, here you can easily identify these fibers. Okay, fibers with high strength are introduced in the soft ductile matrix. These fibers are having high strength. Okay. Now, due to addition of this these fibers having high strength in the soft and ductile matrix or material, the overall strength of this material will get improved. Okay, resulting in better strength and better or high stiffness, high strength, and high fracture toughness. Okay, here in case of fiber reinforced composite, what will happen? Suppose these material we are using in our actual practice, then what will happen if we are using these fiber reinforced composites? Okay, one example I will take here, the vehicle tires. Okay, vehicle tires are made from this fiber reinforced composite materials only. In the nylon material, we are introducing the steels. Okay, or another example I can say here, that is, I will highlight that. Okay, suppose fiberglass or FRP is there, fiber reinforced plastic. I have initially told you fiber reinforced plastic. In this, carbon fibers are introduced in the plastic material. Carbon fibers are introduced in the plastic material. Then, due to this carbon fibers, strength of that plastic material will be increased. Tensile strength is increased. Already, that plastic materials are having softness or toughness in that, and due to this carbon fibers they will increase the tensile strength. Okay, now here whichever the fiber reinforced materials are there, now in this fiber reinforced material, whichever load is applied on the component, okay, whichever load is applied, that load directly it will be taken by that carbon fibers. Okay, that carbon fibers or whichever fiber material we are using, it takes the load, or it bears that load, and the remaining material, matrix material, it will, what it will work, it will just distribute the load, and it will protect that fibers from the shocks. Okay, now that I will explain with this example. In the carbon fibers or in FRP, carbon fibers are there. Okay, these will be carbon fibers. Suppose this is plastic fiber reinforced plastics. Okay, now in that carbon fibers will be there. Whichever load will act, that load will be bared by this fibers. Okay, this will be fibers. Load will be bared by this, and whichever shock is there, that whichever shock is applied, that shock will be sustained by this remaining material, which will provide you the ductility or toughness. Okay, so in this way, this fiber reinforced material will work. We'll explain again. Fibers of high strength are introduced into soft and ductile matrix. Now, strength of soft and ductile matrix will get increased due to this high strength fibers. Now, here, which material we can use as a matrix and which material which can be used as a fiber? We can use both metals and non-metal materials as matrix as well as fibers. The commonly used metallic fibers. Okay, metallic fibers are here. You can I have highlighted here. Commonly used metallic fiber materials are boron, beryllium, molybdenum, tungsten, steels, stainless steels. Okay, generally they are having high strength. Then common non-metallic fiber material used in this fiber reinforced materials are carbon, then glass, silica, alumina. silicon carbide, then boron carbide, or aramides. Okay, these are different non-metallic fiber materials which we are using in this composite materials. Then, as far as the matrix is concerned, the metallic matrix, it may consist of elements like aluminum, copper, titanium, nickel, or their respective alloys we can use. And if it is non-metallic in nature, that matrix is non-metallic in nature, then we can use different types of polysters or different plastic materials can be used. Okay, different plastic materials, it may be thermoplastics or thermosetting materials. Okay, for example, polyesters or epoxy resins, we can use them. Okay, here the one point you have to remember here, that matrix and fiber materials can be metals or non-metals, or they can be metallic in nature or non-metallic in nature. Now, related to the properties of these fibrous composite materials, okay, their properties are very much dependent on matrix element and fiber element. Okay, these are the factors I have highlighted here. These factors will affect the properties of fibrous composites, okay, or fiber reinforced composite material. Now, the very important part is the first part or first parameter is the mechanical properties of a matrix material and fiber material. Depending on these properties of matrix material and fiber materials will affect the final properties of composite material. Then whichever fiber material we are using, the volume of that fiber material, then its nature of distribution and its orientation, whether it is in the flex form or in the tubular form, or whether its distribution is uniform or its distribution is non-uniform. Depending on that, properties of the composite material will be different. Okay, so you have to take care related to this volume concentration of fibers, then the distribution and orientation of the fibers. Then the another important part which will affect the properties of this fibrous composite materials is the firmness of a bond. Okay, one bond will be there in between the matrix and fiber interface. Okay, and depending on its strength, why this strength is important, depending on this strength only, we can decide whether at the higher temperature ranges this material can be used or not, higher temperature ranges or elevated temperature ranges. And the next part is thermal stability of the fibers. Thermal stability means how it will work or will be the behavior of that fiber materials at the elevated temperatures. Sometimes at the or some fiber materials will get dissolved, or they will become soft in nature at the higher temperature ranges. Okay, so that point also you have to take care here, that is at the higher temperature ranges fibers may become soft in nature, or they may get dissolved at the higher temperature ranges, and due to that brittle layer may be formed. Okay, and that material may not be able to provide you the desired properties or characteristics. So while making these composite materials, all these parameters you have to take into consideration. After this we'll discuss the applications and properties. Okay, fiber reinforced materials have these unique properties, that is they have high stiffness, then high strength, high fracture toughness. Okay, they are very and these are very you can say that rigid materials. Then these fiber reinforced materials will provide you very good corrosion resistance and oxidation resistance. And also some materials, depending on the combination, they will provide you a required electrical conductivity or thermal conductivity also. Now, on the some practical applications I have highlighted here for this fiber reinforced materials. Okay, for manufacturing of the vehicle tires, we are using the composite materials, and these composite materials are made from nylon. Here, nylon will be matrix material. It will be soft and ductile, and steel fibers are introduced in this in the form of tubes. Okay, or wires, and due to this, okay, this nylon is nothing but a plastic material. Okay, in this plastic material only we are using steel fibers, and we will get the vehicle tires which we can use. Okay, then the another composite material is okay, in the aluminum. Okay, in the aluminum matrix we are introducing boron fibers. Due to this boron fibers, tensile strength of that aluminum is okay. In this boron fiber reinforced aluminum composite, here the aluminum will be matrix material. It will provide the toughness or required ductility, and these boron fibers are introduced in this aluminum. They will provide you the required tensile strength. And as this aluminum is having lighter in weight, yeah, we can use these composite materials in manufacturing of different aircraft parts. Okay, and these are lighter in weight with very high strength due to boron fibers. We can use them in the aircraft part, manufacturing of different aircraft parts. And then reinforced cement concrete. Okay, here in the concrete, we are introducing the steel rods. Okay, this is another fiber reinforced composite material. This is RCC, and this RCC is used in the construction work. Okay, what is this RCC? The concrete will work as a matrix, and in that we are introducing steel rods. Okay, this is termed as reinforced cement concrete, and this is used in the construction work. Then fiberglass. Okay, in plastic material, this fiberglass is nothing but in plastic material we are using this glass fibers. Okay, in plastic material glass fibers are added, and they will provide you the strength due to that glass fibers, and these fiberglasses are used for in the manufacturing of helmet. Okay, different glasses are there in the helmets or in our car vehicles, different types of vehicles. Okay, glasses are there. These are fiber glasses. Okay, glass glass material will be in the form of fibers, and the remaining matrix will be of plastics. Okay, so used for helmets, cars, jeep bodies, or scooter bodies. Means different in different vehicles we can use these fiber glasses. In FRP, this is fiber reinforced plastic. In plastic matrix, we are introducing the carbon fibers. These are termed as fiber reinforced plastic materials, and as and these are lighter in weight due to the matrix plastic material, and they will have high tensile strength also due to presence of this carbon fibers. We can use this FRP, that is fiber reinforced plastic materials, in manufacturing of different aircraft parts. Okay, so number of examples are there. You can manufacture them different composite materials. A number of practical applications are there for this fiber reinforced materials. So after finishing this part discussion of this fiber reinforced material, we will move towards the second type of composite material, that is laminated materials. If you are having any doubts, you can mention that in the chat box. Okay, now here in the laminated materials, It consists of these laminated materials consists of two or more layers of different materials, two or more layers of different materials, that I will show you in the diagram. This is the laminated materials. Okay, this is one material, then again layer of another material, then layer of another material, like this. Materials, two or more materials will be present in the form of layers. And so these are termed as laminated composite materials. Examples of this laminated composite materials are laminated plywoods, then aluminium alloys, then copper clad stainless steels, titanium clad stainless steels. Okay, alternate layers of these two materials will be there. Okay, in copper clad stainless steel material and copper layers, they will present in the form of layers. Then on steel material, titanium and steel, two materials will be there, alternate layers will be there. So this will be laminated materials. Two or more materials will be there in the form of layer having different properties, and they will give rise to a new material having another specific characteristics. And general properties of these laminated materials are very much similar to fiber reinforced materials. That is, they will provide you a very high strength and good stiffness also. And along with this, their coefficient of very good coefficient of thermal expansion. Okay, means they will provide you low expansion, low thermal expansion values will be there, as a rise in temperature is in the larger amount, the change in the dimension will be very less in this laminated materials. So these are some properties of laminated materials. And laminated composite materials, some applications I have highlighted here. Laminated composite materials are largely used in aerospace applications. Then, as these laminated materials have low coefficient of thermal expansion, low coefficient of thermal expansion, these laminated materials are used in thermostatic controls. Okay, thermostatic controls consisting of bimetallic strips of copper and nickel used to control temperature in ovens and furnaces. Okay, depending on the coefficient of thermal expansion, we can use it for control of temperature in ovens and furnaces to control the temperature of ovens or furnaces. Bimetallic strip is there consisting of copper and nickel, that is made up of, or we can made that with the help of this laminated materials. Now, related to the properties, okay, related to their properties, or some loading effect is there in this laminated material. Okay, in laminated material, depending on the loading conditions, okay, some changes may be there on the properties. So there are two loading conditions in this laminated materials that I have highlighted here. You can see in this diagram two conditions, loading conditions are there. The first loading condition is isostrain or longitudinal loading condition, isostrain or longitudinal loading condition. And second condition is isostress or transverse loading condition. One by one, I will explain it. In isostrain loading condition or longitudinal loading condition, the load is in the direction of layers. Okay, it is in the direction of layer. This is the direction of layer, and this is the direction of load also. Okay, load is in the direction of the layers or laminations or fibers. Okay, that will be termed as isostrain condition. Okay, isostrain condition means in this case, whichever strain is there, okay, strain is there is uniform. throughout all the layers, strain is uniform as far as that layers remain intact. Okay, in this isostrain condition, the load is in the direction of these layers or fibers, and whichever strain is created, that will remain uniform as far as the layers are intact. Layers are intact, strain is uniform. So this is longitudinal loading condition or isostrain loading condition. Then in isostress loading condition or transverse loading condition, load, okay, here you can see that the load is in the perpendicular direction or in the opposite direction to that of layer, direction of layers. This is the direction of layer, okay, direction of layer. Okay, this is matrix or one material and another material, layers or one matrix material or one fiber material. Okay, in this way arrangement may be there. So the direction of loading, here you can see easily direction of loading is perpendicular, or you can say opposite to that direction of the layers or fibers. This condition will be termed as isostress loading condition or transverse loading condition. And in this condition, stress created in the layers, okay, stress created will be uniform. Okay, this is isostress condition and this is isostrain condition. Now, depending on this condition, how the properties will get changed. For that, you have to refer this graph. Okay, when graph is plotted, okay, when graph is plotted by taking here tensile elastic modulus of composite material. Okay, elastic modulus of composite material is plotted on y-axis by taking it as a function of, okay, by a function of volume fraction of fiber loaded under isostrain and isostress conditions. Okay, volume fraction of fibers or volume fraction of layers. It is plotted on y-axis. So depending on isostrain condition and isostress condition, these two curves, okay, with different colors I have highlighted here. In isostrain, the rate is constant here. You can see that increasing rate. You are getting one incline, straight incline line, and here one curved line for isostress. Okay, from these two lines, here we can say that higher, okay, higher elastic modulus is obtained in the isostrain condition. Okay, in isostrain condition we will get the higher elastic modulus, and in isostress condition elastic modulus value is less. Okay, elastic modulus value is less in case of isostress condition, and elastic modulus value is more in isostrain condition. And as I have added note here, higher the elastic modulus, the more resistance is provided by that composite material to the deformation within the elastic range. Means in case of isostrain condition, when loading condition is isostrain loading condition or longitudinal loading condition, at that time elastic modulus is high, which say we can conclude that the more resistance will be provided by that composite material. And if loading condition is isostress or transverse, then less resistance will be provided by that composite material. Okay. So in this case, in this way, depending on the loading condition, we can determine the property related to the resistance also. Okay, so after this discussing the second type, the third type. Okay, third type is particulate composite material or disperse composite material. Now in this disperse composite material or particulate composite material, particles of one material are distributed into the another material, okay, as a mechanical mixture. As a mechanical mixture, particles of one material are introduced or distributed in the another material. Now simply you can say that in particulate composite it is characterized or highlighted as being consisting of or composed of particles suspended in a matrix, and that you can see here. these this is the particulate composite material. Particles of one material are suspended in the another material. This is the base material or another material in that particles, or these are also termed as dispersed composite materials. Now, now this whichever disperse we are doing the adding that particles, depending it may have different shape size, and depending on that shape size and its configuration will get the different properties. Now here, for example of this uh, particle or dispersed composite material is sintered. I have added some example. Sintered aluminum powder. Okay, in this sintered aluminum powder, aluminum material is there. Okay, aluminum material will be base, and aluminum oxide, that is Al2O3 particles will be introduced in that aluminum. Okay, that will be sintered aluminum powder. Aluminum will be base material and aluminum oxide will be particulate material. Then in thoriated tungsten, thoriated tungsten, tungsten will be base material, and thorium dioxide, that is THO2, thorium dioxide will be introduced in the form of particulates in the tungsten. Then third example, thoria dispersed nickel. In this, nickel will be base metal or base material, and in this nickel, thorium dioxide is introduced as a particulate material, or its particles are introduced. Now, related to the properties of dispersed composite materials or particulate composite materials, they have high strength, high creep resistance, and insensitive to the high temperature exposures. Okay, because of this unique characteristics, these dispersed composite materials or particulate composite materials are used in different appliances, different toys, then different electrical products, computer housings, cell phone casings, then different office furnitures, manufacturing of helmets, brakes, and different cutting tools are also manufactured with the help of this dispersed or particulate composite materials. Okay, in this way we have completed the discussion related to the composite material. In this we have discussed what is the meaning of composite material, then its classification, and then their properties and applications. Okay, if you are having any doubt related to this, please mention that in the chat box. Okay, if you are not having any doubt, then I will move towards nanomaterials. Okay, now the next part here is nanomaterials. Okay, now these composite materials or nanomaterials, all these comes in the category of advanced materials. Okay, these are advanced materials, and a lot of research is going on because of the wide variety of properties, and depending on the wide variety, or we can manufacture these nanomaterials or composite materials with wide variety of their properties, hence their applications are also wide. Okay, different number of applications are there. Now we will discuss the nanomaterials. What is the meaning of the nanomaterials? Now, in short, what are the nanomaterials? Now basically, nanomaterials, we can describe them in the material in which its single unit or basic unit size is very small, and it lies in the range 1 to 100 nanometer. 1 to 100 nanometer, then that material will be considered as a nano material. Okay. Now here these nanomaterials have excellent mechanical properties, excellent optical properties, then excellent electrical properties or magnetic properties are excellent, or depending on their shape, size, and the depending on their shape, particle shape and size, wide variety of properties can be obtained with the help of these nanomaterials. Okay, which will be very helpful. Then these nanomaterials can be used, or nanomaterials can be encountered as aerosols. Okay, means in air we can introduce solids or liquid nanoparticles. Then we can use them nanoparticles as a suspension, means solids, in the form of solid we can add them in the liquids, or we can use them as an emulsion. Okay, in liquids we are adding in the form of a liquid, that nanoparticles are added in the form of liquid in another liquid, that will be termed as an emulsion. If nanoparticles are added in the form of solids in another liquid, it will be termed as suspension. If we are adding nanoparticle in the form of solid or liquid in the another air form material, then it will be termed as aerosols. Means wide, in the wide variety we can use these nanoparticles. Then their properties will be different depending on their particle size. Now related as far as their mechanical properties are concerned, as the particle size decreases. Okay, as the particle size of this nanomaterial decreases, then what will happen? The strength of that material, nanomaterial, strength of nanomaterial, hardness of nanomaterial, then its toughness, elastic modulus, all these properties improves. Why this is occurring? Why? As the particle size, when particle size decreases in case of nanomaterials, then the probability of finding defect is very less. Probability of finding defect is very less. Hence its strength, hardness properties are improving. Okay, so this is the unique characteristic. Means depending on the different particle sizes, different properties can be obtained, and we can get different properties as per our requirement. So, and in general nanomaterials have excellent mechanical properties, optical properties, electrical properties, or magnetic properties. Now these nanomaterials can be classified. Okay, first we will discuss the classification of these nanomaterials based on the type of material. Okay, in different ways we can do the classification of the nanomaterials. Now classification of the nanomaterial based on the type of material can be done in four categories: as organic based nanomaterials, then second type inorganic based nanomaterials, third type carbon based nanomaterials, and fourth type composite based nanomaterials. Organic based nanomaterials, okay, here a different material, organic based, inorganic based. In this inorganic based nanomaterials, uh, they these are made from different metals or metal oxides. Okay, different metals like silver, gold, cadmium, copper, iron, zinc, lead. Number of metals are there. Okay, these inorganic based nanomaterials are made from different metals or different metal oxides like zinc oxide, copper oxide, titanium oxide, or magnesium aluminum oxide, or silica, then iron oxide. Okay, these are different metals and metal oxides. From this era, inorganic based nanomaterials are made. Then carbon based nanomaterials, okay, these are made with the help, base will be of carbon. Okay, Its examples will be graphene, then fullerene, then carbon nanotubes. Single walled and multi walled carbon nanotubes are example of this carbon based nanomaterials or different carbon fibers. Then if other than carbon, the base is other than carbon, then that will be considered in organic based nanomaterials. And example of this is dendrimers. Okay, one type of nanomaterial is there, that will be dendrimers or cyclodextrin. Okay, don't go in brief, these names are little difficult. Just other than carbon, if base is there, and that will be organic based nanomaterials. Then composite based nanomaterials. These composite based nanomaterials are combination of any of these three types. Okay, in combination, organic based, inorganic based, and carbon based nanomaterials may be there in composite based nanomaterials. Then the next classification of nanomaterial is depending on their dimensions, and they are classified in four types: as zero dimensional nanomaterials, one dimensional nanomaterials, two dimensional nanomaterials, and three dimensional nanomaterials. Now, zero dimensional nanomaterials, please see here carefully. Zero dimensional nanomaterials are nanomaterials having all dimensions less than 100 nanometer. Okay, all dimensions. If dimensions are less than 100 nanometer, it will be considered as a nanoscale. Okay, in zero dimensional nanomaterials, all dimensions are less than or in the all dimensions in nanoscale. Okay, less than 100 nanometer. All the dimensions are in nanoscale. In one dimensional nanomaterials, okay, two dimensions will be at nanoscales, and one dimension will be on the higher side or in the microns. Okay, in the zero dimensional, all dimensions are in nanoscale. In one dimensional, two dimensions are in nanoscale and one in the micron. Then in two dimensionals, one dimension will be in nanoscale and two dimensions in the microns. And in three dimensional nanomaterials, these three dimensions will be on higher side. That is, all dimensions are extended from nanoscales. All dimensions will be in microns. Okay, so examples in this one dimensional nanomaterials. Okay, two dimensions are at nanoscale and one at micron, and it will have needle like shape. And examples of this one dimensional nanomaterials are nanotubes, nanorods, nanowires, nanofibers. And then examples of these 2D or two dimensional nanomaterials are nanofilms, nanolayers, or nanocoatings. Here, all dimensions are in nanoscale. All dimension, three dimensions are in nanoscale. Here, two dimensions are in nanoscale. One dimension is nanoscale, and zero dimension in nanoscale means all dimensions in microns. Okay, so in this way, depending on the dimensions, nanomaterials are classified in these three types. Okay, here are different shapes of the nanomaterials I have highlighted. This is a nanosphere. Okay, then this is nanorod. This is nanorod. Nanorod, it is 1D or one dimensional nanomaterial. This is nanocapsule. Okay, then nanoshells. These are nanoshells. Okay, and after discussing this classification, now we will discuss in short the synthesis of nanomaterial can be done in two ways. There are two ways of manufacturing of the nanomaterials, and two approaches are there. The first approach is top down process and second approach is bottom up process. And this I have highlighted in this picture. top-down synthesis and bottom-up synthesis. In top-down synthesis, from bulk available bulk material, we are converting it in the powder, and after converting it in the powder, then the nanomaterials are formed. Okay, from bulk material, we are reducing the size, hence it is termed as top-down. From bulk material, we are reducing its size to the nanomaterials. And bottom up, from atom size, okay, from very small size, we are converting them into the cluster. Number of atoms will segregate or come together to form cluster, and this cluster, uh, from that number of clusters, nanoparticles will be formed or nanomaterials will be formed. From small to the higher one, from atom to the nanomaterials, this will be termed as bottom up approach or bottom up synthesis. And from bulk material to the nano materials, from large size to the small size, this will be termed as top down approach or top down synthesis. Okay, here I have highlighted it. And this top down synthesis, we can use different methods like grinding, physical vapor decomposition, and chemical etching like this. Here in the bottom up approach, we can go for sedimentation, then reduction techniques or chemical vapor decomposition also. Okay, now here these are the different methods. We can go for these nanomaterial synthesis. We can go for different methods like physical methods, chemical methods, and biological methods. And in this physical method, uh, mechanical methods are there, vapor methods are there, and that mechanical vapor methods, mechanical milling method is used. And in this vapor method, we can use different methods like sputtering, laser ablation, and laser pyrolysis. Then in chemical method, sol gel method, chemical vapor deposition, colloidal method, and spray pyrolysis. And in biological method, green synthesis. And in that green synthesis, we can use different mediums like plants and microbes. Okay, now here, what point you have to consider? Only largely three methods are there: physical, chemical, and biological. And out of these, physical and chemical methods are expensive and hazardous, and biological method is very safe method. Hence, nowadays very much focus is on biological method of synthesis. Okay, after this, we will now move toward the applications of these nanomaterials. Okay. These nanomaterials are having variety of applications. Now, nanomaterials are used in the variety of applications in the manufacturing processes or different products in different industries. Now, in healthcare also, or in different other industries like manufacturing of paints, different filters, insulations, or they can be used as a lubricant additives. Okay. In healthcare industry, nano enzymes are there, and these nano enzymes are manufactured from the nanomaterials. Okay, number of artificial enzymes are there which can be manufactured from this uh, nano enzymes, and these nano enzymes are manufactured from nanomaterials. And these enzymes can be used for biosensing, then bioimaging. Okay, biosensing or bioimaging is nothing but, 1 minute, that biosensing or bioimaging. Okay, I have collected notes here. Biosensing is detecting, you can say that this biosensing is nothing but detecting the chemical substance, okay, in the biological, living biological component. If any chemical substance is there, okay, that can be detected in this biosensing. And if other activities are there in living substances, living biological substance, other activities are there, that activities are detected by bioimaging. Okay, nowadays you can see that why this is very useful. We are detecting using this biosensing or bioimaging to detect the pathogens in the foods. Okay, pathogens in the foods are nothing but different viruses or bacteria present in the foods. Okay, that are detected with the help of this biosensing and bioimaging method. Okay, biosensors are used if different viruses or bacteria are there in the food, that can be detected by the biosensors. Okay, then tumor diagnosis, and then antibiofouling, and a number of applications are there of these artificial enzymes, and all these enzymes are made from nanomaterials. And then in the paint also, we are using the nanomaterials. Okay, now if you are watching the advertisement on your televisions or in your mobile phones, the Asian paints, they are showing that uh, their paint is long lasting and it can sustain the any weather condition. Okay, Asian paints. Okay, um, if you have seen that ad, okay, of Asian paint. So nanomaterial, they have used the nanomaterials, and due to that nanomaterial only, it improves the ultraviolet rays protection, then UV aging. Okay, these properties are improved due to addition of nanomaterials. And then high quality filters are manufactured with the help of these nanomaterials, and these filters we are using these filters in the water purifier or water filters. We are using the high quality filters, and these high quality filters are made from the nanomaterials only. Okay, in the Sheldon technology, this is the technology used in the water purifier for removing of these small viruses. Okay, and that filter is made from nanostructure or nanomaterials. Then in the air purification field also, okay, in the spread of the virus, MERS is the virus which they found in the 2012, and to okay, and to tackle that virus, in the Arabian hospitals, they have used these nanoparticles or nanotechnology they have used to combat the spread of this MERS virus. Okay. Then in lubricant also, we are using nanomaterial. Okay. Uh, as a lubricant additive, nanomaterials have the ability to reduce the friction in the moving parts. Okay. Then nanomaterials can be used as a three-way catalyst application. Okay, controlling the emissions. Okay, which controls the emission in the vehicles. Then other different kinds of nanomaterials can be used for protection also. Protection also we can use these nanomaterials. Okay, so these are the wide applications of nanomaterials. Okay, in this way we have completed this part of composite material and nanomaterials. In this today's session, I have completed the composite material with their basic concept, then classification, three different types: fiber reinforced composites, laminated composites, and dispersed composites or particulate composite. The nanomaterials we have discussed along with their brief synthesis methods, classification methods, and their different applications. Okay, if any doubt is there, you can mention that in the chat Okay, thank you very much for attending this session based on composite material and nano material. If you have any difficulty, you can mention that in the chat box. Thank you very much.